The final fillet that we need to do is the one between the spoke and the rim front, which is this one here. Let's get rid of the center area, we're not interested in that at the minute. And we'll just shade that up so we can see what we got. So what we're going to do is, if we go into left view here, we've got an intersect between these surfaces here, but you can see that there's a really difficult problem here where the intersect washes out to nothing. So whereas here we've got a very distinct condition where we could easily fillet that, up here it's less easy to do. So what we've got to do in the corner here is manually create a fillet. So let's start off with the easy bit down here. What we want to do is put in a fillet which is about the same size as this one. So I'm going to go back into wireframe, and then I'm just going to measure the distance between that edge there and that one there. So that's about 14 mil. So the way we're going to do this corner is we could just put in a caudal fillet, but instead of that we're going to first of all create an intersect. So we're going to intersect here. Doesn't really matter whether you've got both or single on, to be honest. So press the space bar and there's our intersect. So in the left view that's what that looks like. And we'll do the same thing actually on this one. So that node there. And we've created this intersect between the two sets of surfaces. One thing to notice is that if we look in this top left hand corner, and this is a common condition, is that the intersect should really go to this corner exactly, but it doesn't. It sort of disappears at the last minute, and that's just down to accuracy. It's not that there's anything wrong with the accuracy of our model, but it's just the limits of CAD technology really. So when we come to this corner we need to actually find that exact point. So I'm going to do that by creating some curves on the edges. So if I use duplicate with no rebuild, that will allow me to pick an edge, doesn't matter which one, that one there and this one here, and press the space bar, and we've now got two curves which are exact reproductions of those edges. And let's trim those back to each other. So we'll put trim on. I'm going to trim that one back to that one, and the same the other way. So we've trimmed them to each other. So we've now got an actual corner point, which is what we're going to use for construction purposes. The other thing to notice is that if we go into the left view, that's got a curved shape to it, but if we rotate it around a bit, it seems to be pretty straight. So we want to use that to our advantage. So what we'll do is we'll go into the curve function, degree 1, and we're going to snap one end to, using the control button, to the end of one of those curves, and the other end we use control and alt just to slide it down the end of that curve on surface. So we've now got a straight line. In the left view, of course, it doesn't help us, but if we rotate that around slightly until that's about as straight as we can make it, so it's an approximation of the curves on surface in that particular view, and I'm then going to save that view. So we're going to edit and new group, and that's captured that view for us. Now in this area here we said that the caudal distance of that fillet down there was about 14 mil. So we're going to just start off with a surface fillet in that area with a caudal distance of 14 mil and see what that looks like. So we're going to go for radius, caudal type, G2 continuous, and we want a caudal length of 14 mil, form factor of 1, we'll leave explicit on, and then we can go and pick the two surfaces. Now in this case these arrows, that one's pointing in the right direction but the other one isn't, and the reason is because there's a quadrant of possibilities here. We could have a fillet there, there, there or there. So what we need to do is switch that normal direction around so that it's pointing to where the centre of the fillet is going to be. Otherwise we won't get the right fillet. Now we press the space bar to give us the result. So let's have a look at that in the left direction. Now what we haven't done is put caudal length in there, so that's created as the correct fillet. So you can see in relation to this fillet is about the same size. Of course you could change that to something else if you wanted to, or if the designer has a particular preference for the size of fillet that he wants. We don't want to use that particular fillet, so I'm going to go back to that view there. So we're going to approximate that fillet. This gives us an approximate position of those edges that gives us a 14mm caudal distance roughly. So we're going to pick that curve here. Now you notice that this curve has got its pivot point right up there, and in fact we want the pivot point at this end. So I'm going to say move pivot and use Control and Alt just to drag that down to that end. And then if we use Control C, Control V to copy and paste, we can then move that however we want to, and I want to move it so that it's on this end point here. So this is going to be where our edge is of this fillet, at least, not the one up here but down here. Sometimes that's appropriate to have a fillet edge which goes all the way up there, but in this case I don't think this is going to work. So what we'll use this curve for this area but not for this fillet up here. And then we do Control C, Control V again to create us another copy, and then we're going to move that copy around. So I'm just going to go into left view there and move that to this corner. Let's go back to our view. So you can see that's given us these three parallel lines parallel to the intersect in that particular view. And then we want to get rid of this surface. Don't forget we've also got curves on surface here, so let's get rid of the surface, and then we want to get rid of these curves on surface because that's going to cause a real problem otherwise, because it won't be correct for our new fillet that we're going to create. So we can now use these curves to create the space for our fillet, and by that I mean if we go into the trim function and we put 3D trimming on with project in the view, then we can go and pick. Notice the prompt up there is always the place to look for these messages, but you pick the surface that you want to trim, then the curve, and then the area that you want to keep, which is that one there. So the area that we want to keep, and then we press the space bar. So that's created as our trimmed surface. And we're going to do the same thing on this surface. So it says up here select surfaces to continue trimming, so that's that one there. Then it says select trimming curves as one of the options, and then we want to pick the area that we want to trim. So pick here, select the trim region, so that one there, and spacebar. So we've now got the space there that we want to use for our fillet that's going to go in the corner. Now we can use duplicate again. So that was with no rebuild, to create us a curve on that edge, a curve on that edge, a curve on that edge, and a curve on that edge. And hit the space bar to create those. And then we can use blend. So we're going to create a new blend curve. It needs to be degree 5 because we want a G2 continuous blend in these corners. So we're going to create a blend curve there and a blend curve there, and then build our surface between those. So we're just going to slide along the end of that curve there and just have a look at the CVs just to see what we get, and then another new blend curve there, again picking the curve, not the surface, and that creates us those two curves. Now, like we've done before, we've got the trim version here, but we also want the trim convert version. So we're going to trim convert, And so we're just going to pick that surface there. Have a look at the deviation. So this is with edge deviation switched on. It's giving us an idea of how accurate that is to the original trimmed edge, and obviously we want that accurate, and we want it within 0.001 at the very most. Otherwise, when we construct our fillet, it won't be accurate back to the original trimmed surfaces. So this is clearly not accurate enough because we want 0.001 or less. So what we've got to do there is we've got to increase the V degree. So we'll make that 3, and now that's extremely accurate, so that'll be fine. And then we can pick the next surface, which is that one. And in this case, we've got maximum 0.002, which is a bit closer, but still not close enough. So let's make that degree 4. And now it says it's 0. So that's absolutely fine. So just to clarify that, we've got two surfaces here. So we've got the original trimmed surface, and then we've got the trim converted version. So the trim converted version we're going to use for construction. The trim surface, the original trim surface, is used in the final model just to make a nice, neat and tidy model. Sometimes you don't always want that. Sometimes it's just not possible to have both. But it's always nice to be able to get back to the original surface. If for example, the fillet size changed, we don't really want to have to extend this surface. It may cause errors. So it's better to have the original trimmed version there. And if you want to, of course, you can hide these trimmed surfaces. So let's do that. So we'll put that original node there into the construct layer. And of course, we can have more than one construct layer. We're chucking everything in that construct layer at the minute. Now we're going to put in a square surface in this area. So we got some curves there, which is why it flags up whether do we want the curve or the surface. So that's created this A surface in there. Let's put the CVs on. Always essential that you put the CVs on. And we've got position continuity at the moment, but we want G2 continuity ideally on that edge and also on this edge here, the third edge. So if you look, there's the numbers 1, 2, 3 and 4 which correspond to the 4 edges there. Now that's matched, but the only thing is the degree has gone up a bit. So rather than accepting that, we could put explicit control on, and the maximum degree that we really need is the same as this surface in here, which is degree 4. So this is in the U direction. So let's make that degree 4. So it's still perfectly matched. If we try and drop it to degree 3, the chances are it's going to fail because it's trying to match into a higher degree surface, which usually doesn't work. And the other thing that we've got on, fortunately, we've got collinear on boundary 1. So all of these CVs are nicely linear in terms of the tangency on that edge. And the same thing on boundary 3. Those CVs are all nicely aligned. In this case, if I switch them off, it doesn't make that much difference, but it's important that those are on. Boundary 4, because it's only a curve, that doesn't make any difference whether that's switched on or off. It's going to make no difference in this particular case. So at that point, I would say save your model. It's worth saving your model on a very regular basis. Now the next bit, which is far more difficult, is this corner area. And the difficulty here is that if we were to, say, use that edge to create our fillet, this surface and also the fillet surface come into a corner which is about 45 degrees, and the same on this one. And that's not ideal. It's going to make aligning those surfaces more difficult. Sometimes you have to do it, like everything. But the ideal situation is for that edge to come in at 90 degrees to this curve here. If we're off of 90 degrees, it doesn't matter. As long as we're close to 90 degrees, we stand a much better chance of being able to align everything. So this is what we're going to do. We're going to create a plane based on that end tangent there and a point on this line here. And we're going to intersect this fillet. We'll do the same thing on the other side. And we'll move that plane around, or that planar surface around, until we get an edge which is more or less at 90 degrees on that side and more or less at 90 degrees on that side. At the same time, we want a nice balanced blend curve in that corner. So we've done similar things before. We're going to get rid of these curves because you don't really need them at the minute. So the first thing to do is we build the planar surface. So if we go into curve and create a degree 1 curve, so what we're going to do there is we're going to create the end tangent line, if you like. So if we use Control, snaps to that CV, and Control to snap to that CV, that's one curve. And we're going to do the same thing on the other end. So using Control to snap to the CVs. And then if we go into the X-form function with slide on, and we pick the CV, we've got to be careful which CV we're picking because there's an awful lot of them. And we're going to use that to slide up in this direction. And we'll do the same thing on this one. So that's given us a couple of lines which are tangent to the edge of that fillet there. Then we're going to create a blend curve, and it doesn't matter at this stage what this looks like, but we'll make it degree 5 because it's got to be G2 continuous, and we're going to slide it along that curve there and this curve here. Now when you're sliding it along here, you don't need to use Control Alt because it's a blend curve. It's looking for something like a curve or an edge. So we put the CVs on there. So we've got one line there and a point there, and we want to use those 3 points, those 2 CVs and that one there, as the basis of a planar surface. If we use blend again, but with degree 1 to create a straight line, so what we're going to do is snap to one end of this curve. So we're going to use Control Alt, just drag it down to the end of that curve, make sure it's right at the end, and then we're going to use Control to snap to that end of that curve there. So what that's done is it's created as a blend curve, and the reason for choosing a blend curve is because it's got history. So if, for example, I went and picked this corner blend there and then said edit and pick that location, I can now move that up and down, and you can see the line connected to it is moving at the same time. When we create a surface, we'll also build history into that, so the surface will also update, which is very nice. So we'll build another blend curve degree 1 from this end, so using Control and Alt to slide to the end there, and then Control to that CV there. So we're going to use these to create a monorail surface. So if we go into, now notice how the rail surface function says bi-rail at the moment, so bi-rail at the top, and that's because we've got 2 rail curves. If I could change it to rail curves 1, then we get monorail. So in our case, we just want 1 generation curve and 1 rail curve. So I'll pick these curves, doesn't matter which order you pick them in, and rather strangely no surface gets created, and the reason is because we've got explicit control on. The other thing that we must have on is create history, and the reason for this is that if we now pick that corner blend point there and go and edit that and move it along, we can see the surface updates, which is exactly what we want. So let's go back to monorail, and we'll pick these 2 as well, that one and that one. So that's created us the other surface that we want, and then we want to find the intersect between these planar surfaces and these fillets, and we only need the curve on surface on the fillet itself. We're not interested in a curve on surface on the planar surface. So if we put first surface on and we'll pick that surface, spacebar, intersecting surface is that one, and then we'll do the same thing on this one. So that's the first surface, spacebar, second surface, and there's our curve on surface. There's a good chance, and you can see it on this one, that that curve on surface doesn't quite meet the end. If we try to do, if you weren't sure about this, if you go into trim and we take 3D trimming off and I try and trim that, it comes up with a pink cross on the ends, which shows that it's not a complete curve on surface. So in order to make it a complete curve on surface, we'd have to extend either all of these edges or scale those surfaces. But before we do that, let's just have a look in the left view there. In fact, we'll go to that view where we've got the intersect completely straight, and we'll just adjust these blend points until we've got, first of all, a balanced curve in the corner, which we have. Balanced in terms of, if you imagine a theoretical intersect between that end tangent and that one, it's somewhere around here. And we always want 3 points on 3 CVs on one side of that theoretical intersect and 3 CVs on the other side when we're dealing with a G2 continuous curve, which is the case here. But if we want to move that around, we can pick on edit and move that, adjust that around a bit. But the other thing that we need to be looking at is whether this curve on surface comes in at roughly 90 degrees to the corner, which that one does, and likewise on this one, that one's pretty good as well. So let's just undo that. Let's go and pick that blend point there, and we just move that one along. So it's got to be a balanced shape, but also coming in at 90 degrees, and something like that maybe. So now, to make sure that those curve on surfaces go right across from one side to the other, what we're now going to do, and this will destroy the history, which is why we want to do it now rather than earlier, is we can pick that surface and then center the pivot point. So when we hit center pivot, the pivot point appears in the middle, and we can then scale that in all directions. So it says, you're going to destroy the history, do you want to proceed? And we have to say yes. And the same thing on this one. So we can center the pivot and then scale it about that pivot point. In fact, I've still got the other one selected, but it doesn't matter. So now when we go into trim, and we're going to pick on this one and trim this back here, we get that result. Now, in fact, on these fillets, because this is a pretty difficult corner, what I'm going to choose to do is forget about the trimmed version. I'm just going to do a trim converted version. So I'm not going to worry about, so I'll keep originals off, and I'm just going to create a trim converted version and just work with that on both sides. And the same thing on this one. So we'll trim that back first. There. And do a trim converted version of that one without keeping the original, because the alignment of this corner can be very difficult, and trying to maintain a trimmed version and a trim convert version is often too difficult in a corner like this. So at that point, well, let's just shade up the model so we can see what we've got. So we've got a hole in the corner, which is where we want our corner fillet to be, and we've got to that stage where we should now save that model. Another critical point at which it's worth saving. Before we try and put the corner fillet in, we're just going to do a bit of tidying up. So let's take the shading off. Now you remember that when we built this fillet here, that we actually built that from some construction surfaces, which were the trim converted versions of trimmed surfaces before. If I pick one of those surfaces, you can see the edges of that fillet get highlighted in pink there, and that indicates that there's some history there. So we do want to get rid of this history because that's going to cause problems potentially. So we'll go and pick everything and then just say delete construction history. And we can also get rid of these locators down here, not that they're really much in the way. And we want to hide these surfaces here, so we're going to open up the layer construct and we want to get rid of that surface and that surface. We're going to assign to that layer, but the ones that are trimmed versions of those, so that one, that node there and that node there, we'll assign those to spoke F. So now when we take construct, let's construct layer off and just shade that up just to confirm that we've got some geometry there. So we've now got the trimmed versions, which is what we want to be looking at. The other thing that we want to do, because we did a trim convert on these surfaces here, trim convert is an approximation. It's not 100% accurate. It'll be a very good approximation, but what we do need to check is that we've still got the alignment on these edges. So if we go into the Surf Con tool with G2 continuous alignment there, and just check everything around the geometry that we're trying to create. And then also there's that edge as well. So that all looks absolutely fine. The other thing that we notice, that if we go into hardware shade, we've got this trimmed surface here, which we've trimmed to the old fillet there. We actually want to extend that out this way so that we can cover that area in the corner. Because when we put our fillet in, which is going to go to this edge and these edges here, there's going to be a little bit of a triangular shape there. And the best way of filling it is just to extend this surface. So let's untrim that. And we'll keep the curves on surface there, but we just want to make sure that where this curve on surface goes to, because that one is from the old fillet, and if you look, it actually goes all the way along there, and we don't want it all the way along there. We want it to stop at this point. So that curve on surface we can delete. Really important to manage the curves on surface. And what's making things a bit difficult to see is there's some curves there which we don't really need. We could put them into the construct layer just in case we ever need them, but probably unlikely. And you can see that that surface extends to this point, which is where we built it originally. Let's have a look at the CVs on that one. Now we just check that the surface continuity here is okay. There's no reason to think it shouldn't be. And then we'll go into extend. So we're just going to extend this surface this way so that we can try and cover up that hole there. So extend, extrapolate with merge on, and we pick that, pull the middle point, and you can see the continuity is still there, which is great news. There's another problem with this corner, is that if we take the shading off, what's likely to happen here, we've got this blend curve coming around here and it's feathering into this edge, and what often happens is that it feathers in and then the system decides that it's within tolerance of that edge, and you'll find that it stops short of the actual corner. So the solution to that is, first of all, we need to just make sure there's no history on there, and then we'll also get rid of that locator because we don't need it now. And then we're going to extend that surface in this direction. So we're going to make it slightly oversized, which seems a bit of an odd thing to do, but we know that when we extend it with extrapolate on, it's keeping the original shape at 100%. So we'll still have the G2 continuous continuity there between that edge and this surface here, but what we've done is given ourselves a bit more surface there so that we can actually trim to this line as well as all of these curves. And that means that we can then control more precisely how that curve comes into that corner and make sure that it doesn't cross over and end up with a trimmed surface which stops short of that corner. Now that curve isn't exactly on that surface, but that doesn't really matter because we can sort that out when we create our surface. So we're just going to create a surface from these 4 edges. So we're going to go into the square surface function. So we just pick these edges, make sure that we're picking the ones that we want. So that's a curve, we want the actual surface itself, and we'll put the CVs on. And that doesn't look very good at the minute, but part of the reason is that the degree going around this way is only degree 4, and it should be degree 5 to match into these bounding surfaces here. So we'll make that, increase that to degree 5, and now we've got a much better condition there, it's matching on those sides. We also want to make sure that we've got linear on first edge, third edge, which you have, and the fourth edge, which we haven't. And also on the fourth edge we need G2 continuity. So we've got G2 on first, third and fourth edges. Now that doesn't always pass the continuity check, as you can see. In fact, what that's telling us is not only the curvature is failing, but the fact that the tangency is in yellow does mean that we're failing the tangency test as well. And what we'll do is take history off, because that will again be one of those things that could cause us problems. So this is just typical of what you'll get when you put a surface between 4 edges, and what you've then got to do is some hard work to bring that all up to match on all sides. So we're going to use a line 8, and we're going to pick on that surface and we're going to align it in, we want curvature matching ideally, collinear into that edge there. And again, check that history is not on, because otherwise you might find that you're fighting the system every time you go around to a different edge. Sometimes history is good for matching, but other times it can cause unexpected problems. So that is not matching in curvature at the minute, but it is matching in tangency. But we'll just go around the next edge. You just got to keep experimenting. So this edge here, by trying to match it in curvature, is now pulling these edges off in positions. The position's failing here. So I'm going to make that tangency instead. You can actually down here specify the continuity check. So I can either look at the tangency, or more interesting is to look at the curvature and see where we are. And if it's coming up yellow, we know that it's passing the tangency but not the curvature. So you can see that when you change that to tangency down there, it passes the tangency. So that's passing tangency. That's only passing position, not tangency. So let's go onto that right hand side and try again with that. And we just have tangent on. So now that's not passing curvature, but it will be passing tangency. Again, we can confirm that here. And we'll do that over there as well. So now, although I've only matched it in tangency, it's actually matched that in curvature now. And that one again is pulling it away from this edge, so we've lost the curvature there, and we haven't got curvature there, but then we've only specified tangency. So we've got tangency on these two sides, and we've got position on this side. Now after going round those 3 edges and just using the new align tool, so sometimes you have to work with the new align tool or the old align tool. It's worth trying both. Usually the older one, the 08 one, will work better on these conditions, but you never know. So going around those 3 edges and just putting on G1 continuity has resulted in, at least we've now got tangency on all of those 3 sides. So what I'm going to do now is, you can see these CVs are nicely lined up here because that's pretty much collinear, but they're all over the place here. There's a big SE shape going through these CVs, and it's quite difficult to see what's going on as well. In fact, what we'll do is take those CVs off on the surface over the top, just to make things easier to see. Before we do any more alignment, then we should try and tidy up these CVs. So I'm going to just pick out that surface and use Object Display Hide Unselected, so it's the only thing that we can see. And then we're going to do this trick where we can get these CVs onto planes. So we go into plane with 3 points and press go, and we want to snap to the CVs, this one, that one and that one. So I'm going to press Control and snap some way away from the CVs so that we can be absolutely clear that that's where it's got to. So that's created as one plane. Press the space bar to complete that, and then if we click on left here, we'll get the view looking straight down that plane, and this line here is the one that we want to straighten up, and we simply do that with planarize hole, single, view based, closest boundary, which means it's going to move these CVs down the tangent lines. That's really important, and we get that. So we repeat that process. So the 3-point plane, using Control to snap to the CVs. Make sure that you're away from the CVs, because that usually means it won't pick up something else by mistake. Click on left, planarize hole, and we repeat that process 4 times in total. Planarize hole again, and then the last one, 3 points, that one, that one, that one. Press the space bar, go to the left view. So that left view is relative to that plane. So now if we go into Object Display Visible, that'll bring everything back. And it's getting a bit busy here. So now you can see these CVs are much better aligned, and fortunately we've still got the tangency alignment here. At this point it might be worth saving it, particularly when you've done an awful lot of iterations of trying to align on several edges, moving CVs around. It's just worth saving it so that you can always get back to that point. So at least we've got something that's tangently matched, if not curvature matched at this point. Now the other thing that we do want to match in is this edge. It shouldn't be too far off this top surface, but we should align that in as well. And we'll keep these planes. Those planes could be useful if we wanted to align those CVs again. And as usual, what we'll do is use pick construction there, and we can pick all of those planes and just put them on the construct layer there for reference if we ever need them. So we're going to do an align. We're just going to do G1 in fact, and we use project here. So we're going to pick the edge, which is that one, edge of the square, and then we want to match it or align it into that surface there. And you can see that we must have explicit control off because it suddenly increased the number of spans. So we want to put explicit control on, and we're aligning it. We're going to project those CVs normal to the surface there, and you can see it's only position, well, it's not even position matching actually, it's failing the position match. And so the solution in that case is going to be to increase the degree, which is often the case in a corner as complex as this. So this is the V direction, so we want to increase the degree. Let's do it one step at a time. So we've had to increase the degree to degree 7 in this case. We could try putting G2 on, and that's actually worked. And let's see, with our extra degree that we've got here, maybe we can do the other edges as well. So that's only giving us tangency on that end. So what we'll do there is just wind that back a bit and just make it G1. Let's pick this edge here, that one there, into there, that surface. And we've got G1 at the minute. Let's try G2, see if we can get it to that point. And we actually want edge on there. Now it's moved position off on this edge, but we have got G2 on this edge. So you can see how iterative this process is. and then we want to align that edge, try aligning that in G2 as well, and that's showing that it's tangent matched but not G2 aligned. So you can also try align 0.8, which often works better on these ends because we've got the collinear option there. So let's go into there, we'll put collinear on, we'll try curvature, and then we'll go into this edge, and that just doesn't want to know, so we'll keep that as tangency. It's quite odd that that edge has actually changed. Maybe if we revert, so we're back to a better condition there, so that's better. So the only edge that isn't matched down here is that one that's only tangency matched at the minute, and this top edge, obviously that's not matching at all at the minute. So we're going to we'll try using this align on this edge here. So we're going to have to align it into that curve on surface which was projected when we used align, and clearly explicit control needs to go on there. So that's getting closer because that's tangency matched, as you can see. So when it's yellow curvature, it's implying that it's tangency matched. Let's try curvature, and finally we've got that curvature matched on that side and that side. So this is definitely a point where you want to save that and breathe a bit of a sigh of relief. So we'll make that a new model. So the only thing really is that edge there, and you might decide that it's actually not critical that that tangency isn't curvature, because with curvature in your construction settings you're really putting in a number, and the number is fairly arbitrary. What really matters is what this looks like. What we could do is, if we go into the information window and change that to curvature and just see what we've got, because sometimes you'll surprise yourself and find that that actually is curvature matched for some reason, and it's not always obvious how that happened. But if we put the comb on here, and you can bump up the scale under G2 as well if you wanted to, you can see where that problem is in terms of the curvature. So if you remember that the edge of this surface here, the edge is G0, the next row of CVs controls the G1 continuity, and the third row controls the G2 continuity. And what we can try, is moving some of these CVs on the third row to try and modify that condition, that continuity condition down here. So in other words, that's going to control the curvature going into that edge. What we've got to be careful of is that these CVs also can control the continuity in the left and right directions. But it's only from the fourth point onwards, so this is first, second, third, that fourth point doesn't have any effect on the curvature in that direction, on that edge. So only the first 3 points in that direction affect the curvature alignment there. The same on this side, so those 3 points affect curvature that way. So as long as we only move those 2 points, they will affect curvature this way, but not that way or that way. So if we go into X form, and we could use normal movements of the CVs, and these will be very small, so we want the mouse sensitivity right up, maybe not quite to the top to start with, but let's just see what happens. So if I try and move that point, and you watch the curvature display, those spikes, you can see they come down. Often they come down and then they go back up again, but if we're lucky we can move that, and that's fixed that G2 continuity issue. Again, I'm just going to save that as the same name. And if you want a quick look at what that looks like, bearing in mind we've got a surface over the top of everything at the minute, but if we go into Object Display Diagnostic Shading and just put on one of the zebra stripes there. Now we can't see those zebra stripes in the corner because we've got this surface on top, So we can either pick that surface and make it invisible, or you can just look around the other side of the model. But let's just make that invisible. And you can see we've got some quite nice zebra stripes in that area, which is what we'd expect because we've got G2 continuity. And the only way to get anything better than that would be as if you built this with G3 continuity, and then you'd get an even smoother result, but that's a pretty good result. So we take that shading off and we'll go into Object Display Visible just to bring that surface back. So there's that surface. So the last thing we need to do now is to trim this surface. Now we've got, if we pick that surface, we should see where the curves on surface are. So we've got curves on surfaces around here, then there's a gap, then we've got that one as well, and then there's also this area where we extended this surface out, and so we need to put a curve on surface in this area and one on here as well. And like we said before, we've got to be very careful that curve on surface actually goes all the way to the end there, otherwise we can have a problem. So we'll just use project curve on surface normal, and we're going to pick that surface there, and then we want that edge and this edge here. And then if we go and pick that surface, trim it. Now you can see the green dots, which are very useful in this area, because we want to make sure that that green dot goes right to that corner, which it seems to do. So that's the bit we want to keep. And let's just do a final check on this. So G2 continuity here, and there's that edge as well, of course. And we'll put our zebra stripes on. And if you want to just delete all of those locators, we don't need them now. Well, one trick with locators actually is you can put them on a layer. So if you wanted to bring them back, so we could call this locators, and we could just pick all of those locators, because that's handy sometimes. The only problem is that sometimes they'll get corrupt because you've got rid of a surface or moved something or duplicated it, and there can be a problem there, so you just have to watch out for that they're live. But we can bring those back at any time, which is great because you can just declutter the screen. Object Display Control, and we'll have everything off here so we don't have to see all of those CVs, and press F12 and you get all of the edges off as well. And so that's our final fillet there on the spoke to rim area.